We're going to work with equations doing graphing tonight. With our equations, we're only talking about linear equations in this case. There's other types of equations, but we are only talking about linear equations. Linear equations can be in several forms, but I'm going to talk about one and I'll mention two. But they can be in slope-intercept form, and they can be in standard form. Again, these are not the only forms, but these are the two I'm mentioning, and I'm only going to go in depth about the slope-intercept form today. Slope-intercept form, it lets you know that these are the two things that you should be able to see when you're looking at the slope-intercept form of an equation. It is y equals mx plus b. Why is it called the slope-intercept form? Well, it's called the slope-intercept form because m, or this number, the coefficient to the x, is the slope. And b, which is the constant by itself, is the y-intercept. So it's the slope-intercept form. If you see an equation that is, let's say, y equals 2x plus 6, then the slope is 2 and the y-intercept is 6. Slope is the amount or the steepness of the line, and the y-intercept is the place or the point where the line crosses the y-axis. The place or the point where the line crosses the y-axis is called the y-intercept. I always have my students to remember an intercept. If they're thinking about football, you think about the interception. It's the place where the ball and the person on the other team, they meet. The ball gets intercepted, or they cross and meet at this place. Okay? So if we had something like y equals negative 2/3 x minus 3, then here our slope is negative 2/3. It means we got a negative slope. And our y-intercept is negative 3. It crosses the y-axis at 0, negative 3. Now that we know these two things, we can use equations. We can use these equations in slope-intercept form in order to graph. Okay, let's do an equation that we're going to graph and go on from there. So let's do one. Y equals 2/3 x plus 1. Again, we have our slope as 2/3 and our y-intercept as 1. Let's get us a graph piece of paper that we can use with our equation. This is the one we're doing, y equals 2/3 x plus 1. The first thing we want to do when we're graphing, you want to plot the y-intercept. So step 1, plot y-intercept. So our y-intercept here is 1, and our slope here is 2/3. Y-intercept is 1. The place where it crosses the y-axis is positive 1. Putting our dot there. The next thing you want to do is go from that point to the slope. So from that point, you want to rise over run. The slope is the rise over the run. The amount that it goes up or down over the amount that it goes left to right. In our case, we have 2/3. So we're going to rise 2 and we're going to run 3 from this point. So we started at y-intercept of 1. We're going to rise up 2, means we're going here 1, 2. We're going up 2 places. And then we're going to run a positive 3. 1, 2, 3. 1, 2, 3. This is now our new point. We went up 2 from here. We did a rise of 2. We did a run of 3. Rise over run. Rise is either up or down, and then you always go to the right. So if it's a positive slope, you go up to the right. If it's a negative slope, you go down to the right. Always to the right. Positive or negative means whether or not you go up and down. Then you connect these 2 points. You have these 2 points. You connect them. Make sure you have a good graph going there. And this is the equation of that line. The equation of y equals 2/3 x plus 1. Let's do another example of this. Say we have y equals negative 1/4x minus 2. This is our next example. We want to identify our slope. Slope is negative 1/4. We want to identify our y-intercept, which in this case is negative 2. This whole thing is the y-intercept. Okay, negative 2. Our first step, step 1 again, is to plot the y-intercept. Our y-intercept here is negative 2. So we go to our graph. Oh, let me write this equation here. Y equals negative 1/4 x minus 2. Okay, we want to plot the y-intercept of negative 2. 0, negative 2 there. Our slope or rise over run. Let me see from there. We want to go down 1 and right 4. How do we know to go down 1? Well, the slope is negative. The slope is negative, so we're going to go down. This is a negative slope. So from this point, we go down 1. This is our rise. And we go to the right 4. 1, 2, 3, 4. Stops here. Run of 4, a rise of negative 1. Once we have our new point, we have 2 points. All you really need is 2 points to make a line. You take these 2 points, put them together. Up 1/4. There we go. And then you draw a line between these 2. And you've got your line for this equation. Why? It's a negative slope. This line is going down and to the right. A positive slope goes up to the right. Negative slope goes down to the right. There we are with those 2. Now, what do we do if we can still have it in y-intercept form, but we decide or we find out we want to find points and graph them a different way? Let's graph using a t-chart. That was graphing using slope-intercept form. Let's graph using a t-chart. So a t-chart is just that. It's a chart that looks like a T. That is a t-chart. So we take our equation here. Let's use y equals 2x plus 3. You can use this equation. Okay, we put in our x value. Then y equals 2x plus 3. It doesn't matter what you select for your x value. Any point on the line, it's up to you, whatever is going to make it easy to, get some y values. Let's go with that. So let's start with 0. 0. So we're going to have y equals 2 times, we're substituting 0 in place of our x, plus 3. This equals 0 plus 3, or y equals 3. So the point we have here, if we're looking for an xy point, our xy point here is 0, 3. We substituted a 0 for the x value, and once we did that, we found that y equals 3. So this is our x value. This is our y value. In case you need a reminder of coordinate points, the first one is always x. The second one is y. Let's pick the value 1. Put that in place. Y equals 2 times 1 plus 3 more. This is 2 plus 3, or y equals 5. So our point here is 1, 5. If we pick another one, let's pick a negative number just to give us something interesting. How about we go with negative 1? Y equals 2 times negative 1 plus 3. So we've got negative 2 plus 3, or y equals positive 1. So our last point we will do is negative 1, 1. You could stop with just the 2 points because 2 points is sufficient for a line. But if we go on to 3 points, you keep yourself from making some type of error when you are doing your computation. If you make some kind of mistake, if you have 3 points, you have a better chance of catching an error if you're using 3 points. Okay, so we have 3 points here. We've got 0, 3, 1, 5, and negative 1, 1. Those all go with this equation. So let's put those on our graph here. 0, remember when you're graphing points, you start from the origin, you go left, right, then up and down. So 0 is the x value and 3 is the y value, 0, 3. Then you go to, from start at the origin, we go to 1, and then we go up 5, 1, 5. Or then we have negative 1 here for this point, negative 1, 1. Notice all these points are on the same line, which is what they should be. Can we see those? Yes, we can. All those are on the same line. We can connect our dots. And there's the graph for the line of y equals 2x plus 3. We also could have used the slope-intercept form again. The y-intercept was 3. The slope is 2 over 1. So we go up 2 and over 1, and we should still be at the same point. There we go. Both ways work. It all comes down to preference or what you're asked to do. Let's do one more example here. How about y equals negative x plus 1? I'm going to use a t-chart again because I want to show that method. We did 2 with the slope-intercept, so now let's do 2 with the t-chart. And then our xy value over here, so that way we have our coordinate point when we're finished. Again, let's start with 0. Y equals negative 0 or 0. There's no such thing as negative 0, but we'll go with it from here. After we do this, y equals 1. Our point here is 0, 1. Let's use 1 for our x. Y equals negative. We're substituting 1 for the value of x. Notice this negative is a part of the equation, so you can't get rid of that. It stays with it. And then we substitute the 1 in place of the x. Plus 1. Negative 1 plus 1 is 0. So our point here is 1, 0. Let's just pick one more point for good measure. I'm fine with using 2. We could use a negative number. Either way would matter. Y equals, you have your negative. We're substituting in the 2. Plus 1 here equals, y equals negative 2 plus 1 is negative 1. So our 2 points, our point here, so our coordinate. Coordinates are there. We have 3 points there we're looking at, 0, 1, 1, 0, and 2, negative 1. So 0, 1. We start at 0. No left or right. We go up to 1. There's point number 1. 1, 0, 1, and we don't go up or down. And then we go to 2 and -1. 3 points again. Make it a smart thing to do to graph your points is to use 3, at least 3 points. Safer for you if you do that. Okay, let's connect our dots. Make sure you put arrows on the end, letting you know that it continues on and on and on. This is the equation y equals -x plus 1 has been graphed there. Okay, so we talked about 2 methods. We talked about graphing equations based on the slope-intercept form. The slope-intercept form, which is y equals mx plus b, where m is the slope, or the number in front of the x is the slope, and the constant that is by itself is the y-intercept. You graph the y-intercept first, and then from there you graph your slope. Okay, or you can use a t-chart. Substitute values, and get 3 points on the line and go with that. Slope-intercept form t-chart. These are not the only 2 ways that you can use to graph linear equations, but these are the 2 that I'm covering tonight. If you're interested, there are others that we will have in the course that is launching very soon. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemath.com, where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathhelp.com. We look forward to seeing you there.